Now if you are talking about particularly uh,
Yes, sir.
how to run, so basically basic steps, you already know that how to run a particular program. You need to compile, then you need to run Java commands. So if you are talking about any other particular frameworks like Spring Boot, so you create a basically any particular code, you use the build tools, either a Maven or the Gradle, and then you run some commands to clean and install, and then you will basically build the jar. Then we have seen the concept of a containerizations, correct? So containers advantages are lightweight footprint, minimal overhead, portability across the machines, right? Easily you can then there is a no such dependencies on the host machine, right? So it will have its own libraries, softwares, networking and everything, correct? So without doing setup of any single thing, still you can run your application with the some simple commands, and you can have all the configuration available in the form of images, correct? So we create the image, working image, and we share this working image with the multiple other people, and you can create a containers, correct? So it will basically minimize the gap between the developers and the operations team, right? So that you can have a much more better performance, right? So we have seen multiple other scenarios. We have seen a multi-container setup with the Docker Compose, so you don't need to even install for any database or anything. So database will also be getting installed, your Java Spring Boot application will also be getting up and running, and then your entire setup will be up and running. So easily you can migrate, setup, and you can run it, right? Good part is that if you will use and follow this practice, so continuous integration will also help to us. Third point is, when we are talking about microservice architecture, so microservice architecture is very much tightly coupled with the DevOps, because when you have hundreds of services are running, hundreds of services are nothing but hundreds of your microservices. So how you will deploy, scale, or you will have the backup services for that. So you cannot do manually each and every service, you go manually deploy and set it up. So there will be some other setups and requirements also for 100 services. So how you will manage and how you will check the health analysis, log aggregation, many such other things you need to do it. So at this, every company and the industry demands for microservices, right? So there are different tools also required to support for NFRs for the microservices. So when we are talking about different tools are something for monitoring, right? If you are talking about checking the health analysis, if you are talking about aggregation, log aggregations, right? If you are talking about, you can say, connectivity of the particular services, many such other things are required. Security also. So security is not directly belongs to DevOps, but all the steps are basically for you can say monitoring, log aggregations, and all of the things are basically we need the, you can say, separate containers who can monitor to your running containers. Okay. So that is the basically we have seen it. Now basically how you can run any particular container. So basically you can just run, you can use a docker run hyphen d, or you can use a particularly a docker run hyphen p for mapping the port. So these are the switches you can, a single and isolated Linux process in the single machine, correct? So this is a basically we have seen the docker command. But when we are talking about DevOps challenges for multiple containers, so now we have two containers, you can have 100 containers, and these containers are not for Java, there can be some other containers for different others inbuilt tools. There are containers for database, there are containers for Java. So how you will avoid the port conflict? There are some containers are using some ports. There are how to scale up the containers, means when you wanted to create a replicas of a containers, so how you will do it? How to manage them in a multiple host? If you wanted to manage, some of these containers are running on one node, some of the containers are running on the other node, because your host machine doesn't have too much memory, right? So you cannot have run the container which requires much more memory rather than your host. So you have to properly categorize these many containers will run on this particular host or node. correct? So these are something we can call as a nodes, right? So you can have a multiple nodes. So what happens if a host has a in trouble? So how you will handle it? So how you will basically, if there are a particular container is not responding, correct? So how you will basically manage it, and you can say that okay, these many how we need to create a new container because this particular container is not running. So you need to update them as well, right? So let's say new version of your image you have created. Earlier you have the image for 0.0.1. Now you added some much more functionality. You are publishing it to 0.0.2. So do you want to basically down the application completely and then you will make the application up? Or is there any other way also where you can running application you can just change that particular image, right? So in simple applications, if people are very new like you are not basically having any good understanding for enterprise applications. In enterprise applications, you cannot have access to production applications. So only their operations team generally give it to you all the data. If you require the database, if you require logs. So how you will access these logs and how you will monitor and do some check it. And let's say if you are 100 microservices are running, so how you will aggregate the logs, how you can find out this particular request is flowing from one service to another, then another service to another. Got it? So it's very difficult and painful. So you have to have a proper setup for, you can say, monitoring, logging, and there are many other for managing, creating or scaling. So many such other things you need to take care. So for that, traditional approaches of your deployment will not going to work and help it to you. Okay. So these are the challenges. So that's why we are looking for something called as a orchestration, and that is nothing but the called as a Kubernetes. So gig for elements also root of the word governance. So you can say this is a container orchestrator. So supports multiple cloud and bare metal environments. Multiple in, you can say cloud, it is supporting Azure, Oracle, it is supporting IBM, AWS, GCP like that. Okay. Open source. Now this is the way you can just see, right? So developer people, what they do, they basically put the code into a source control management, something called as a Git or SVN. With the help of CI/CD, right? We will promote this our code through the automation with the help of this ops team onto a particularly on what we can call as on the Kubernetes infrastructure. So we have the master node, and we also have something we called as a control plane node, where we have the API server Kubernetes, and through which we basically it will connect to all other nodes. Okay, so registry is nothing but which we have used for storing your images. So we'll pull this image from your registry, and we will basically up and running your containers into an particularly what we can call as the infrastructure on the basically Kubernetes. Okay, we will see in some other layer little deep how this Kubernetes architecture works. So here you can see it is running here database, running as a Tomcat. Each particular node has some different setups. So here in this node we are running a Node.js, Spring Boot, MySQL. Here we are running Postgres, Node.js, Java, like that. So you can have each particular node you can have based on the requirement in company. You can run a different applications. So there are different objects into an Kubernetes. So Kubernetes concepts are basically what you need to understand is, so there is a something we called as a pods. So one or more containers shared IP. So one particular pod can contain a multiple containers. Correct? So generally we don't create a containers directly, we basically create a pods when we are talking about the Kubernetes. So these pods, you can have a multiple pods on the same node, means on the same machine, something you can think. Okay, then there are something we call as a services. Services are basically, it is not having the containers, but services are basically helping us to connect to a particular pod. So grouping of pods acts as one has a stable virtual IP. So if let's say your pod is not responding and there is a new pod is coming, but still your endpoint will not be getting changed. That's why we need a service. Service is basically the external endpoints through which we will connect to a pod and the containers. Okay. So one pod can have a multiple containers, one or more containers, but ideally you should have a one particular pod has a one particular container. Correct. So it has a shared volume, shared resources, shared life cycle. Now there is a replication controller and the deployment. So ensures that the specific number of pod replicas are running at any one time. Okay. So that is the basically role of this. Labels are nothing but something we call as a tags. So you can also tag it for a pod, tag it to a services, because when you wanted to, one service will connect to a pod. So this service is used for this pod. So it is basically through labels. So we use that particularly a match selector and selector. So we will use that particular labels. These are, this particular service is basically for endpoints, providing endpoints for a prod. So it is through a particularly what we can call as the labels. There are many other ways also we use it for labels. So it's the key value pairs associated with the Kubernetes objects. Something we call as a tagging. Okay. So that is a basically. Now apart from that, here is also a concept of a volumes. So there is a external data if you wanted to attach it. So that is also you can use it for removable volumes as well. So there are many more objects are also there when we are talking about Kubernetes. Now concept of a pod, group of containers live and dive together, share IP, secret level and volumes. So secrets are nothing but which is generally used for, you can say if you have any other certificate base, or maybe if you have keep password user ID and password based secret. So these are basically you can use it for, you can say different authentication purpose you can use it. Let's say if you wanted to connect to a Docker registry, you can create one secret type of Docker registry. If you wanted to create any generic secret, you can create a generic secret for which you can use it for any other purposes, right? So you have application administrator log collector. So these are basically accessing the volumes like that, and this particular pod will have a one particular IP here. Okay. So this pod will be exposed or will be accessible through a service. So what is the definition of a particular, so here we also use the YAML format. Okay. So we can have a API version. Kind is nothing but what type of, what is the basically object we are creating. Are we creating a service, or are we creating a pod, are we creating a volume, persistent volume, or we are creating a persistent volume claim, or we are creating any other. So these are basically a nothing but a particularly a kind. Metadata is the data about the particular data here. So metadata you can specify name. So labels you can specify any name. Let's say labels you can have a name, run, whatever, anything you can attach a label to this pod which can be used for any other purpose. So in the spec sector section you will see the containers. So in the containers you will give any name to a container, and this container will be created from which image, so you can specify the image name. So the image name whatever you are using to create a Docker container, the same image name you can specify here. Okay. So using this image, giving this name of the pod, giving the name of the container, this pod will be getting created. Correct? So this is the way you can just see how it can be used and how it can be basically the system can be built it. Correct? HDN overlays network. Now we will discuss these two slides little later. So replication controller and the deployments. So when we are talking about that deployments, so deployments are nothing but you can also create a deployment. In deployment you can specify the multiple objects as well, and in deployment basically can actually it is creating a nothing but that pod as well. Okay. So basically deployment will be a one more level up on top of the pods. Basically with the help of deployment also you can create a containers. Okay, so there are some much more additional details you can specify, right, when we are talking about the deployments, replicas and many such strategies and many such other things. Okay, so that is we will see now. So you will see app is basically cool, environment is day, version is v1, node, right, on this node you will see version is 2 something, environment is prod like that. So everything in the Kubernetes can have the labels. You can specify the labels, right? Based on the labels, you can access and you can say use for different purposes. Okay. So concept labels also you can have multiple labels. So every object you can label it, based on that you can access it. So some of the pods you can say for it is for basically for production purpose. Some of this for just for other purposes. So you can just specify the labels. Correct. So like this app is cool, environment is dev, so you can have multiple key value pairs for a particularly level. Metadata is very common in this YAML file. Whenever you are creating any pod or deployment or service, every file you will have a API version, you will have a kind, you will have a metadata and labels and spec. These four things are very common. Correct. Now there is a concept of a service. So node 1 you will have a pod, node 2 also you will have pod 1 and pod 2. So there is a two pods are there. So in that case, if you wanted to use this pod, right, access it, so we need to have a particularly an external endpoints, because these pods can be getting down or maybe can be any challenges. So there should not be impact on any other client service, any client which is trying to access it. So there will not be any changes on the IP and other things. So, and if you wanted to access this, these pods are basically accessible inside the node only by default. Actually it is in what we can call as is cluster IP. So there is a three types of services. One is for node port, one is for cluster IP, and one is for node balancer. So outside world, if you wanted to access this particular pod through any URL or any REST API or any other thing, it has to be exposed via the service. So which service is associated with which pod? It is basically we will use the label selector. Okay. So this service will tie up with this particular pod with the help of labels. So if I will specify label selector is match label is app is equal to cool, here you will check it app is equal to cool. So what are the pods are having that labels are app is equal to cool and environment is prod, these are the basically you can say pods will be exposed. So whenever we are connecting to this service will send the request to this pod. Correct. So how the service YAML file looks like: API version, kind is the service, metadata, name, labels, and you can specify the port and the selector. The selector is nothing but in the pod file you have given whatever the labels, these are the labels you can specify. Port is basically what is the target port which is available on the pod, and what is the port you are giving and exposing it. This is a very simple service file, right? Like this. Okay. So there is also concept of a service discovery using the environment variables, MySQL port, MySQL TCP, and all these things. So there is a concept of persistent volume. So the way we have seen the concept of a volume into a Docker, here is also we have, right? So this volumes, basically you can have a static and dynamic. Another thing is that it you can pluggable volumes. Means if these containers got destroyed or killed, still you can have, you wanted to have the data. That is the basically whole and sole purpose, right? Another thing is that if you wanted to process this data, means something you wanted to give the data to one container or something you wanted to take the data from the container, in both the cases you need the volume. So let's say if you need some script you want to execute on particularly in container, you need the volume. Let's say if your container is generating a logs and you wanted to process and see number of exceptions and all these other data and do some other analysis on the log, so you can process these logs and check it into some other container. So for that your container will put the log into some other volume. So that is for persistent volume. Rolling updates is basically how you wanted to update your image in the container. So right now you have that, let's say 0.0.1. Now you wanted to have 0.0.2. So what are the basically strategies you will use it to update this? Means do you wanted to keep this entire, let's say you have 4 containers are running as a replica to share the load. So do you wanted to keep it down for all these one, or you wanted to keep it for two down one at a time and two down two will be running? So first we will update these two, then we will update other twos. Correct. So this basically you need to have a particularly this strategy is a rolling updates, and then you can specify, right, max, right, the percentage is basically. So if I will say there are 5 particularly replicas we have created for a particular pod, in that case if 20% is basically max unavailable, so always it will be a 4 pods will be always running. So one pod only you can get it down one at a time. Okay, like this. Persistent volume I told you, right? So you can specify basically provision them, right, high level of extraction. Now this persistent volume you can directly access, and also there is a concept for persistent volume claim. So pods can connect to this persistent volume claim through a persistent volume through a persistent volume claim. So you can attach that, access this persistent volume through a persistent volume claim. Okay, so that is also we can do it. So in that case if we just basically don't want it to use this particularly a persistent volume, right, so we will just remove, there is a one particular layer here. So persistent volume claim is one more layer in between pod and the persistent volume. So I will show you or give the details what is the purpose of the persistent volume claim and when you should use it and when you should not use it, right? So there is a concept of a binding of a particularly or attaching that volume, right? So here we have there is a detail, so I will share with you. So rolling updates I told you, right, if you have 4 pods, right, replicas are 4, how you can basically provide that particularly rolling updates, correct? So these are the basically some of the objects. There are some much more objects like volumes, persistent volume claims, correct? There are ingress network policies, correct? Then there is a basically something we called as a roles, right? So there are a many more things are there into a Kubernetes, but at least we will see bare minimum things which you required at least to understand at start is for pod deployment services. These are things basically you should be comfortable, and if you have a little bit understanding on volumes, so that is good enough for to start with the Kubernetes.